Hello students, today we're going to be taking a look at page 11 through 12 notes, and then your homework will be 11 through 12 even. Let's get started. We're in section 5.2, which is entitled Solving Quadratic Equations by Graphing. So we recall hopefully from last section that a quadratic equation has the form ax squared plus bx plus c equals 0, where a cannot equal 0. We've also seen this written in a form where instead of it's set equal to 0, it's set equal to y. And we'll take a look at various versions of that where maybe you do want to look at y equals as opposed to setting it equal to 0. We're going to also take a look at roots of a quadratic equation, which are solutions or a solution of the equation or the 0 or zeros of the related quadratic function, like I said, when y equals ax squared plus bx plus c. The zeros of a quadratic function are the x-intercepts of its graph. Therefore, finding the x-intercepts is one way of solving the related quadratic equation. So we're going to take a look and kind of gauge with this very first example the techniques that are probably already in your toolbox or tool bag from Algebra 1, but we're going to attack it probably a little bit differently in some instances. Solve x squared plus x minus 6 equals 0 by graphing. So first, graph the related function f of x equals x squared plus x minus 6. In other words, turn the problem into, well, this is really just like saying y equals, right? F of x is the same as y. But essentially replacing y with that is still okay. It's still a function that we can graph and interpret. And as far as the x-coordinate of the vertex, which we also learned, we can assess that by doing negative b over 2a. So for our purposes on this problem, we've got an a value of 1, a b value of 1, and a c value of negative 6. So negative b divided by 2a would just simply be negative 1 divided by 2 times 1, or negative 1/2. So the x-coordinate of the vertex, again, is just that, negative 1/2. Also, we can assess that the axis of symmetry is x equals negative 1/2. The graph is already presented here for us, so I want to highlight probably at least 3 points, the first of which you can see is negative 1/2 comma negative 6 1/4, which we can assess simply by plugging in negative 1/2 into the function. Yes, if you do that, we'll do that here. So I'll say y equals this time. And again, maybe using parentheses as we've done in the past with substitution makes our lives more simple. With that particular math, you'll end up with negative 25 over 6, which is the same as negative 6 1/4. Okay, so that particular point, your vertex, so go ahead and plot that. And hopefully you also recall that we will need minimally 3 points to graph a parabola. And the very first usually ends up being the vertex. And then from there, it's really up to you. I do really like the ordered pair. Anything that happens to cross the x-axis or the y-axis, I do like the ordered pair 0, negative 6, and I like negative 1, negative 6. Now, that only, again, speaks to this point and this point. As you recall from last section, we also discussed the nature of symmetry. So these two ordered pairs have the exact same y-coordinate because their x values are equidistant from the axis of symmetry. But really the problem isn't quite done. And the reason it's not done is because the goal of this particular problem is to find where the parabola crosses the x-axis. So you, after trial and error, frankly, you will end up with 2 points. One is at 2, comma 0. And the other is at negative 3, comma 0. We will approach these answers much more efficiently with different techniques besides graphing, but today we're primarily talking about graphing. But as you can see in the XY table, if you continued on where plugging in 1, you'll get negative 4, plugging in 2, there you go, you get 0. Plugging in negative 2, should also yield, so if I go in the other direction on our XY table, plugging in -2, for example, should also yield a y of -4, because again of the symmetry that we discussed last section. Well, finally, -3, if you test this, you'll see it ends up giving you a y of 0. So your two x-intercepts, aka zeros of the function, are in fact 2 and -3. Let's move on. So let's take a look, again, using the related graph of each equation to determine its solution. So x squared plus 2x minus 8. Let's take a look. So let's highlight right off the bat, because we are going to be graphing here. Let's highlight our A as 1, our B as 2, and our C is -8. So for the very beginning, we'll again find our vertex by doing -b over 2 times A. So I did -2 divided by 2 times 1, or -2 over 2, which ends up just simply being -1. We had -1 comma something. Okay, that's the x-coordinate of the vertex again, but it's also the axis of symmetry. Okay, so I'm going to highlight that. I'm also going to highlight 2 additional points. Okay, I do happen to like 0, and I'm going to move that value down a bit, because I'm going to probably find more than 3 points on some of these questions, just to kind of prepare in advance for that possibility here. So -1. I do like 0. Okay, and if I pick 0, I do believe -2 should also be nice to interpret and look at. But let's plug in -1 and kind of see where that takes us. So if you plug in -1, remember, we're taking a look at the function as y equals, instead of 0 equals ax squared plus bx plus c. So we'll say y equals, well, we're plugging in -1 for x, so -1 quantity squared plus 2 times -1 minus 8. If we do that math, we got -1 squared, which is 1, plus 2 times -1, or -2, so 1 minus 2, so -1 minus 8, and in fact we end up with their -9. So -9 is the y-coordinate. All right, plugging in 0 and actually -2, we could just do 1 and be good with that, because those, again, should have the exact same y values. So if you plug in 0, well, heck, that's the y-intercept. So 0 comma -8, -2, -8. Again, this is enough to graph the parabola. It is not, however, the answer to the problem. We want to find where the graph crosses the x-axis. So as it turns out, again, these 3 points are enough to graph, but let's continue. And let's also write the vertex officially here as -1, -9. -3 and 1 are 2 more points we can choose. As it turns out, -3, though, or 1 for that matter, if you plugged it in for x, it won't yield 0. And that's really the goal here, right? Considering where it crosses the x-axis, y needs to be equal to 0. Well, let's just try that. 1 squared, that's 1, plus 2 times 1, that's 2. So you have 1 plus 2, which of course is 3, minus 8 is -5, and that's not going to give us what we want. So again, consider, well, not just plugging in 1, but also -3, well, same value. Let's go to -4, and let's go to 2. I'm writing these down because these end up being the appropriate solutions. In other words, x-intercept. So if you plug in, let's try 2. 2 squared, that's going to give us 4. And then plus 2 times 2, which of course is still 4, or again 4. And that math yields what? We've got 4 plus 4, which is 8, minus 8, which is 0. That checks. So not only will 2 yield 0, so will -4, because of the principle of symmetry as we discussed prior to this particular section. So let's plot all 5, or if we plot 3, that would be fine. -1, 2, 3, 4, and 2. And then -1, comma 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we go ahead and plot those 3 as opposed to 5, it's really up to you. I'll leave it at 3 and be done with the parabola as such. Just for the sake of putting a nice finishing touch here on our graph, I'll draw the axis of symmetry. and label it x equals negative. Okay. And you can label other things, of course, like the vertex, for example. But that's, I think, fair to answer this question. And by the way, in total, because we did the math appropriately with these two values, we can say our final answer, and officially x's would be enough to suffice, -4 and 2. Okay, let's try another question here. I'm going to try a problem in which maybe the solutions aren't as obvious or even in existence. For the sake of argument, and to be kind of mindful about what you learned in Algebra 1 again, it's been a while, but let's kind of consider the three versions that we're going to kind of see here and lead us into options to not just graph, but other maybe algebraic approaches. So one option as far as a solution goes is to see a parabola cross at 2 points, across the x-axis at 2 points. Another option would be to see a parabola cross at only 1 point. And then the third option would be to see a parabola where it never crosses the x-axis. So this would be 2 solutions, 1 solution, and 0 solution. So the problem that I'm going to choose here, number 5, will be a little bit different than number 1, as you're about to see. Approach it in the same manner, though. So looking at number 5, we've got an A of 1, a B of 4, and a C of 6. So to start the problem, we'll do our analysis with negative B divided by 2A. And if we do that math, that becomes -4 over 2. So simply -2. Plugging in -2, if we do that math, that becomes -2 quantity squared, which is 4. I'll write that down here, plus 4 times -2. Plus x. That math lends itself, and I'll write y equals again here, lends itself to what? 4. We have then -8, which is -2, plus 6. Correction, 4 minus 8, -4, excuse me, plus 6, so +2. Okay. There's my vertex, -2, comma 2. And one thing we need to address before we jump in with maybe even finding 2 more points, I still will do that, but before I write things down, let's consider the following idea. This parabola, because it happens to have a positive a value, this parabola will open up. That's how all parabolas will take shape if, in fact, the a value is positive. If the a value is negative, the parabola opens down. Again, a concept you may recall from Algebra 1. So for this particular problem, because the parabola we know opens up, well, if the vertex is already above the x-axis and it opens up, well, it would hopefully make sense that it never touches nor crosses the x-axis. Let's prove that, though, officially by just finishing it up with an xy table. Delete that. So this little xy table, again, will include my vertex. I won't go as far as to making more than 3 points. Because again, I already know in advance how my answer is going to unfold. So if I picked, let's say 0, I tend to lean towards y-intercepts if I can when I graph these, unless of course there is a solution, then I'll have to extend that out to the actual x-intercepts. In this case, there won't be any in existence. So I will pick 0, and because 0 is 2 units to the right of -2 on the x-axis, we'll go 2 units to the left, in other words, -4. Plugging in 0, that's simple. 0 squared plus 4 times 0, that's just 0, plus 6, that's 6. And again, because of symmetry, you don't need to work for that because those two values end up being identical. So 0, comma 6, 1, 2, 3, 4, 5, 6, and -4, comma 6. So -1, 2, 3, 4, and there you go. We've got our 3 points. We've got our parabola. Again, we knew in advance it was going to open up. And of course, it doesn't have any solutions. I'm going to write my axis of symmetry again for good measure. But technically, this problem has no solution. You could even write this little notation we've used in the past.